4.1 Areas and distances. Problem number 3 says the velocity v of t in the table below is increasing on the interval 0 through 12. Part A says find an upper estimate for the total distance traveled using n equals 4 or n equals 2 subdivisions. So I'm going to start with n equals 2 subdivisions. We want the upper estimate, so the upper estimate formula is, in general, this. The upper estimate is the sum from I equals 1 to n of the function at the specific point times the change of the interval. Well, so for r sub 2, we have the sum I equals 1 to n, or 2. N is 2 in this case, so we do 1 to 2 of, in our example, our function is the velocity. So velocity at time I times the change in time itself. And in general, the formula for delta x is the change in the interval over how many times you split that interval up. So what this implies is for r sub 2, the change in time is a constant number. So going to the interval, our b is 12, our a is 0. So we have 12 minus 0 over, and we were given n equals 2. So now we have 12 minus 0, which is 12, divided by 2. That gives us that delta t is equal to 6. Now we just have to sum these up. So we need to figure out what is the velocity at time 1. Well, since this is an upper estimate and we're counting by 6's, well, this is a group of 6. And so we would take this upper estimate, the highest rectangle, which would be the 6th. So I would need this output number, 39. So the first one would be 39 times 6. And then I would add that to the second interval set. So we went from 0 to 6. Now we're going from 6 to 12. And now I'm going to take this, the upper estimate, which is this 12, which its output is 47. So my v of t sub 2 is 47, and my delta t is still the 6. So this was v of t sub 1. We broke up our interval into 6. So when we took this 12 and divided it by 2, that means that we cut the interval off at 6. So the lower or the upper estimate for the first n is this 6, which yields an output of 39. And from 6 to 12 is still 6. But we're taking an upper estimate, so we have to multiply it by this 47. Well, we can also use the distributive property to undo this. So now we would have 39 plus 47, which this is like 6 times 86, which 6 times 6 is 36. So you get 6 and then a 3. 6 times 8, 48, 49, 50, 51. So for r sub 2, we have an answer of 516. Well, r sub 4 is similar. take the sum I equals 1 to 4 of v of t sub I times the change in t. Well, now we need to figure out what delta t is. Delta t is, well, since we're breaking it up into 4, b and a are still similar. We have 12 minus 0, but since we're breaking it up into 4 pieces, we have to divide by 4. So 12 divided by 4 gives us a 3. And that's telling me that our delta t is 3. So when I use this formula, I mean, I have to count every third. So this will be the first. This will be the second. This will be the third. And this will be the fourth. Because it's an upper estimate, we had to take the upper point of that interval. So this would be the upper estimate using 4 subdivisions would be 3 times 35 plus another 3, because we're changing from, first it was this interval, now we're changing from this interval, which 6 minus 3 is still 3. But now I'm multiplying by this 39. Plus 3 times 43 plus 3 times 47. Well, when we simplify a little bit more, we can rewrite this as 3 times 35 plus 39. That's 74. 74 plus 43. And then plus 47. Well, 43 plus 47, that's 90. 90 plus 74, that's 164. Let me just double check my math. Yes, I was correct. 164. And so when we multiply this out, we would get 2, bring up a 1, 6 times 3 is 18, plus a 1, 19. Bring up another 1, 3 times 1 is 3, plus a 1 is 4. So when we use 4 subdivisions, we get this answer. And when we use 2 subdivisions, we get this answer.